Here you're being asked to balance a redox reaction in acid. Here I've included the half reaction method for balancing redox reactions, but one thing to note about a multiple choice question here, in any properly balanced redox reaction, all the charges should be balanced. So if we look at the correct answer here, marked in green, we got 4 H pluses, that's plus 4 on the reactant side, 2 Fe2 pluses, that's 4 more pluses for a total of plus 8 on the reactant side. On the product side, we got a plus 2 here, and then 2 Fe3 pluses for another plus 6, also for a total of plus 8, and the charges are balanced. Now that doesn't guarantee that it's balanced properly, but at least you don't know, you know for sure that it's not wrong. If we look at like the first example here, water is neutral, MnO2 is neutral, but Fe2 plus is plus 2, and there's 2 of them, that's a total of plus 4 on the reactant side. On the product side, we've got Mn2 plus, we've got 2 Fe3 pluses, that's another plus 6 for a total of plus 8, and then 4 H pluses, giving us a total of plus 12. And if the charges aren't balanced, that is definitely not a properly balanced redox reaction. And what you find is that actually none of the other answer choices have the charges properly balanced and could be eliminated. But again, you still should know the rules for balancing half reactions. So let's go ahead and balance this. We got it split up into half reactions, step 1. First half reaction here, balance all elements except oxygen hydrogen while the manganeses are balanced. So rule number 3 says balance the oxygens by adding water. So in this case, I need 2 more oxygens on this side, so I'll add 2 water molecules. Rule number 4 says balance the hydrogens by adding H+. I now have 4 hydrogens on the product side. I need 4 on the reactant side, and so I'll add H+. So because we're adding H+, here you'll see that the rules by default balance a reaction in acid. Rule number 5 says balance the charge by adding electrons. On the reactant side here, we've got a total of a charge of plus 4 with those 4 H pluses. On the product side, we've got a total charge of 2 plus with just the manganese there. Whichever side is more positive gets the electrons until the charge is balanced. And so we'll need 2 electrons on the left-hand side. That way both sides have a total charge of plus 2. And this is the balanced half reaction for MnO2 and Mn2 plus. So if we go to the other one here, this one's a little bit easier. There are no elements to be balanced here in this case. The ions are balanced, there's no oxygen, there's no hydrogen, and we go straight to balancing electrons in step 5. And in this case, this is the more positive side, and it's one more positive, so we need just a single electron. So in this case, we see that the manganese reaction is a 2-electron reduction with electrons being a reactant. The iron half reaction is a 1-electron oxidation, but the electrons lost here by iron are the electrons gained by MnO2, and so those electrons actually have to balance. And so in this case, we need to double this whole reaction. That way it's also a 2-electron process, and then we can combine these into one overall reaction. And if we do that now, put all the reactants here from this half reaction, and then all the reactants on this one, again, keeping in mind we're doubling everything. So it'll be plus 2 Fe2 plus, and then all the products together as well. So here Mn2 plus 2 water molecules, and again doubling this, so 2 Fe3 plus, and again 2 electrons here as well. And in any properly balanced redox reaction, the electrons should definitely cancel. And here we've got nothing in common on both sides. So we've multiplied by factors, we've combined the half reactions. And we're supposed to cancel anything that shows up on both sides of the reaction. And in this case, there's nothing that shows up on both sides of the reaction. This is the balanced reaction. And notice it matches 4H plus MnO2 plus 2 Fe2 plus going to Mn2 plus 2 H2O plus 2 Fe3 plus. And then again, the charges are balanced on both sides. Notice steps 8 and 9 aren't necessary because those are only for balancing in base, and here we're asked to balance in acid.